Hello everyone. Today I'm going to go over a general method for factoring quadratic equations, and this will actually give you a way to factor anything that's quadratic that you want to factor. Now, it's not particularly simplistic, but it will factor any quadratic equation that you want to factor. And the way to do that is to have what I have below here. You have, and I'll read off, for ax squared plus bx plus c, and I skipped a lot of space there, but anyway, as long as a is not 0, we don't want to divide by 0 after all. But anyway, moving on, we have a, next line, a, and then parenthesis, x plus b over a, and then plus square root of the entity b squared minus 4ac, and then we close that off and divide by 2 over a, and then for the next set of and then multiplicative times the next set of parentheses, we take all that and multiply it by the next set of parentheses, which is x plus b over 2a, and times 1 minus that entity, that radical over 2a. And you're thinking, well, how did you get that? Well, it involves using the two things in the quadratic formula. I do x minus one of the roots in the quadratic formula times x minus one of the other roots in the quadratic formula, if you want to know the truth. And if you don't see that, don't worry about that right now. So that is a corresponding factorization, is what that is. So we have a corresponding factorization. Now, below I do a particular example, 3x squared plus 4x plus 1. Now, you could factor that old school, and I know what you're thinking, well, why on earth would I want to do that if I could factor that old school? Namely, because I want to show how it works, and there's many things that you can't factor old school, which I'll do shortly. But let's do this one for now, bear with me, and then I'll get to something that we can't factor old school. Now, the a, for this one, a is 3, and we do x plus b over, a copycat in the formula, the general formula above. A is 3, so now we do x plus b over 2a. Now, if a is 3, keep in mind, in this a squared plus bx plus c, b is 4. Now, we'd really have, let's see, we have b over 2a, that's 4 over 2 times 3, it's 4 over 6, but that's still 2/3. 4, 6 reduces to 2/3. I went ahead and just kind of skipped that and reduced it. I didn't want to write 1,000 steps down. You'll have to forgive me there. But 2/3 is correct, because b over 2a gives you 4, 6, which is 2/3. And then radical b squared minus 4ac. Again, b is 4, and if you square b, you get 16. 16 minus 4ac, that's 4 times a is 3, c is 1, and all over 2a. But now 2 times 3 is 6. I went ahead and just cut to the chase and did the multiplication, put the 6 down there. And then in a similar fashion, copycatting the next set of parentheses, the second set there, I did x plus 2/3 minus entity, the fraction, square root 16 minus 4 times 3 times 1 over 6. And some of you may already be jumping ahead in your brain. You're like, well, by PEMDAS, the 4 times 3 is 12. 12 times 1 is still 12. 16 minus 12 is what, 4? And then the square root of 4 is 2. But hey, that's 2/6. But hey, that's 1/3. And that's what I did. The 1/3, I went ahead and did like 5 steps there, guys, because I just did not feel like writing all that on the board. Again, I go inside the radical. I do 4 times 3 times 1, I get 12. I do 16 minus 12, I get 4. But I do the square root of that 4, and I get 2. So I have the fraction 2/6, but I take the liberty to go ahead and reduce 2/6 to 1/3. So I have the 1/3, and I have it right. It's hard not to get my fingers in the way here. But I have the 1/3 right here. Let me hold it right-handed so my finger won't. And I have the 1/3 right here. So those are the 1/3 that I'm talking about. Now, and again, just in case, that this one here and this one here. And I got it by cleaning this up. I'd get 2/6 and reducing 2/6. Okay. But now, 2/3 by associativity, I can add 2/3 and 1/3 to get 3/3, which is 1. I can subtract 1/3 from 2/3 on that other one to get 1/3 positive. Okay, and I get 3 times x plus 1 and x plus 1/3. Now, guys, keep in mind, what I do next is a little mysterious. I can distribute that 3, but I can't distribute it through both. I can only distribute it through one. Now, let's distribute it through the one that's going to annihilate the fraction, shall we? So leave x plus 1 alone and distribute 3 across x plus 1/3. So if I distribute 3 through x plus 1/3, I get 3x. So let's see, this 3 hits this x and I get 3x. And this 3 times 1/3 is 1. So I get 3x plus 1. So I get x plus 1 times 3x plus 1. Now, again, so hence, after a long time doing, a lot of work, we got 3x squared plus 4x plus 1 equals 3x plus 1 times x plus 1. And, it commutes, so you could put the 3x plus 1 on the left if you wanted to, and the x plus 1 on the right if you wanted to. But anyway, y'all know that. You all probably know that. But you're like, well, that's much ado when I could have just did that in a more short and sweet fashion by guessing and checking. That's true, but what if you have something more general? What if you try something you can't do old school like this? Now here, this is x squared plus 2x plus 5. And again, this is x squared here plus 2x plus 5. Now here I have no choice. I can't factor this by traditional methods, even if I wanted to. Now again, I use this general woodwork right here, the x plus b over 2a minus this big thing here, and then this the analogous thing here with all pluses, and then don't forget your a. But in this case, a is not going to do much because here a is just 1, so I can ignore a. I could not do that last time, but I can here. Now b is 2, c is 5. So keeping those in mind, since a is 1, b is 2, and c is 5, well, what of it? What can we do with that? A little bit. So we have x plus b over 2a, which is, let's see, that's 2 over 2 times 1, which is just 1. So that's where this 1 comes from right here. I went ahead and just cut to the chase. And then plus radical b squared minus 4ac, and sorry for the glare there, but that's going to be, so now b squared is 2 squared, which is this 4 right here, minus 4ac over 2a, but a is just 1, so we can just ignore it. Okay, and then in the analogous case for x plus 1 minus that. But guys, look at that radical, that square root there. We got 4, that's 4 minus 20, because 4 times 1 times 5 is 20, so we got 4, and then we got 4 minus 20, so we got 4 minus 20, that's negative 16, and be careful, the square root of negative 16 is not just 4, it's 4 times I, where I is the imaginary number. And then if I take 4i, and divide 4i by 2, I get 2i, or 2 times the imaginary unit. So I went ahead and cut to the chase there. I didn't feel like writing all that out. So you're at the mercy of my verbal explanation there. So I have x plus 1 plus 2i, and I have x plus 1 minus 2i. I'm just doing what's in red right now. And that's the factorization. So this is the factorization of the original thing, x squared plus 2x plus 5. And notice it's good to have now. That would not have been so easy to have seen. Now, what if we want to... Now, one last little thing. What if I want to set 3x plus 4x plus 1 equal to 0, move my fingers here, notice I can just good old-fashioned factor that by algebra 1 or 2, and just get 3x plus 1 times x plus 1, and you solve those. Remember, you set 3x plus 1 equal to 0 separately, and you'll get x equals negative 1/3. Like you subtract the 1 over, divide by 3. And if you solve x plus 1 separately, you get x equals negative 1. Man, that's not so bad. Now this one's kind of weird. If you solve it, well, if you set the left one equal to 0, you just do the polar opposites. Like For the x value that makes this 0 would be -1 minus 2i, because you want -1 to hit the real 1, and you want -2i to hit this positive 2i here. And then in an analogous fashion, for the other one, you want -1 plus 2i, because you want this -1 to hit this positive 1, and you want this positive 2i to hit that minus 2i. So those are your two solutions. And I know what you're thinking. Well, could I have done the quadratic formula to have solved this guy? Yes, you could have. But remember what I was doing in the first place. I was wanting a formula that would factor for me before I ever was even doing zero solving. I was asking for the factorization of ax squared plus bx plus c. And the factorization of ax squared plus bx plus c is this big old thing right here. All this stuff. Well, I'm moving too fast, but you see it. It's the x plus b over 2a plus radical thing, and then x plus b over 2a minus radical thing over 2a. But anyway, this is a good thing to memorize in its own right. I'm not saying it's as important as the quadratic formula, but it's a great thing to know. Don't forget the a in the front, because a is not always equal to 1. We don't want to get too spoiled. But anyway, thank you for the video.